Well, hello and welcome back. Now, the video you're about to watch on the Icom IC R8500 is a long video, but there was no other way to make it any shorter. I could have split it into parts, but if you don't like some of it, and there are bits where I'm completely confused and making no sense and talking like a gibbering idiot, but try and stick with it, skip through some of it, because it does have a happy ending. So I hope you enjoy it, and on with the video. So on the bench today, and has been many other times, is the Icom R8500 receiver, which is a very nice receiver. It's also a scanner, but anyway, it covers the frequency range 100 kHz to 2 GHz, all modes: wide FM, narrow FM, AM, single sideband, CW. Lovely receiver. Had it about 15 years. I think they were around £1,500 when they were new. I probably paid about £600 for it, I think. But this one has a problem, which I will now demonstrate. Okay, so we have a flashing display, no audio at all. Now, it also has a bulb out, but that's a minor problem. This first started happening about 5 years ago. When I would turn it on, sometimes it would work and sometimes it wouldn't. It would just flash its display. And now it doesn't do anything. It always does that. So it doesn't receive, it doesn't do a thing. Although you can still tune it, but that doesn't mean anything. So if you Google this fault, as I have, it suggests there's a PLL problem, and it has 3 PLLs in it, and they use a Motorola PLL chip, which are no longer available. Well, you can get them, but they may be dodgy. So I spent many hours working on this thing, and almost got to the point of giving up on it. Icom UK wouldn't be interested. They'd say it was too old. There is another possibility of a company that do repair amateur radio equipment, but I'm going to give it another go. Now, in the past I did order some new PLL chips, although I think the PLLs are working okay. I bought some from China, which is always a bit dodgy, and I put those chips in it about a year ago. Made no difference whatsoever. But it's an incredibly complicated device, and I'm struggling with it. But so I'm going to take it apart and have another look. Well, before we take it apart, let's have a look at the schematic. And this is basically the whole of this is to do with the local oscillators and PLLs. So you can see how complicated it all is. And there's a microprocessor of some description up there, which I don't understand. But the Motorola PLLs, and there's 3 of them. Here's one of them here, MC145 190F, which are no longer in production. and as far as I can tell, when they're working, you get a lock detector signal that comes out on pin 2 and is filtered, and that goes up here into, it says 2LD, and that goes through a couple of digital transistors, and that ends up going out on this line here called LCT, which goes to the main board on the top of the receiver, and that I believe that's something to do with the lock detection signal. And it also has another one which comes from the other PLL up here, and as I think I've marked it +5, and that must have been when it was working, and I believe these are working anyway. But that's the second lock detector, and that ends up on this one. I don't quite understand the purpose of these diodes pointing the wrong direction, but that would in theory mean they're reverse biased. I don't know at the moment, but and then we've got another signal which is labelled COUL, and that comes all the way from over here from this board, which is the converter unit, which basically is responsible for making it work above 1 gigahertz, 1 to 2 gigahertz, and it produces a mixing signal, I think, of 1 gigahertz. We'll have to have another look at that sometime. But anyway, we've got another PLL here, which is fed from this side a reference signal of 15.1 megahertz, and it calls it ref. That comes from the main crystal oscillator, which is a 30.2 divided by 2, and that reference signal comes into this PLL chip here, and Rare's Wizardry produces an output of 1 gigahertz somewhere in all this stuff here. But strangely enough, the lock detector signal on this one is connected to that 15.1 megahertz reference line via a choke, so it doesn't upset the 15.1 megahertz. And I am assuming that they're using this line to send a lock detection signal back through the reference input to that board, and that is what is basically labelled COUL. So another lock detector, presumably. Now I've obviously marked it. I don't know when I marked it. Might have been years ago. As 5 volts, probably when it was working. So I need to investigate that again. The other interesting thing is, if you unplug this reference signal from this board, the display stops flashing, but the receiver still doesn't work, even below 1 gigahertz. This is responsible for 1 to 2 gigahertz. This board is responsible for. So although you get a constant display, then there's still no output from the receiver. But I now need to take it all apart, really. Okay, so bottom and top panels taken off. This is the top side, which I'm not too interested in, and there is some RF stuff going on in there and here, but this is the main board with the IF amplifier and filters and audio amplifier, and I believe somewhere on there is a microprocessor probably underneath, so I can't see one on top. But what I'm more interested in is the PLL board, which is underneath this shielding can, so I need to get that off. It's not so hard to get it off, but it's hard to get it back on again. It's awkward. I suppose I ought to turn the power off. Okay. So that is the PLL board, and down there is the main reference oscillator, 31.2 I think it is. But not the easiest thing to work on, because some of the PLL chips, well, one of them at least, is in underneath one of these cans. Another one's over there, which you can't see because the camera's crap as usual. There's one of the PLL chips which I changed there, and one of them's underneath one of these cases, but cans. But what I wanted to check really was, I've done it all before but I've forgotten, this lock detect signal, which I'm assuming that is, which comes out here on a multi-way connector, goes to the other side, which I believe must be this one. That's the connector, I'm sure. If I go into pin 1 of this connector, it says it should be 13.8, which is more or less what I'm getting, 12.5. That's near enough. Now, pin 2 is the lock signal, I assume anyway, and that is, well, nothing virtually, and I know I'm on the right one because if I go to pin 3, it should be 24, and it is 24, so I think that should be a high signal, +5, but what do I know, maybe it's a low when it's a lock detect. But if I go back, if I go and look at that, phase lock loop signal, that's one of the PLLs anyway, and I'm sure pin 2 is lock detect. Take it from me, that's 5 volts, and I think that, if I remember reading the data sheet correctly, lock detect should be 5 volts. with some pulses on it. So I think that one's working okay, but I want to check this later on with a spectrum analyzer to see what signals I'm getting. Now I've got to try and find the other PLL, so I'll just turn the camera off while I take the tops off these cans. That is in here, so I need to take this one off. Actually, I got the wrong one. It's not that one, it's this one. But that's where the other PLL chip lives. And ignore all this, that's my own modification. You don't want to know about that. But yeah, the other PLL chip's there, and I've replaced that one as well. So if I can very carefully, and I can't see very well, to get onto pin 2. Oh, that says 28 millivolts. I won't show you the meter, but because it's too difficult, I might short some pins out. But that should, if it was doing what it should do. But then again, this board is only used above a gigahertz, or 1025 I think. So if I change the frequency, so yeah, I've now got 1111 megahertz. It's not too important as long as it's fairly high, above 1025 anyway. I try and get back on that pin. And it still says 28 millivolts. So I think that's not working. But I've no idea why. And the other interesting thing was, which I think I might have said earlier, is this is the reference going onto this board, 15.1 megahertz. Move it back a bit. So that's the reference, but it also carries this lock detect. And if we look at the screen display and I unplug that, you can see me unplugging it. If I unplug the reference, it stops flashing. But that doesn't really help, because it still doesn't work. No, it doesn't. It still doesn't work. I'm sure it doesn't. So as I said, this carries the 15.1 megahertz, and that's about where I've got to. This video is going to go on and on and on and on and on, and most people would have got fed up with it by now, I would think. Because, you know, I'm fairly good at this stuff, but there are limits. Understanding how something this complicated works is somewhat difficult, especially when the microprocessors are involved in the equation. What I really would like to do, but I don't think it's possible, is that signal I was looking at there, which is lock detect, I believe, which goes to the other side of the unit. I'd like to stick a 5 volts on that, but it's rather hard to do that when you've got a connector that's soldered onto the board without cutting it. I wonder what it's doing now then. No, I disconnected that, whatever it was. Well, that's interesting there. That signal there, LCT, is now saying 4.5 volts. So disconnecting that 15 megahertz reference, which I've lost. Yeah, it's hanging down here. It seems to have changed the status of that signal that I assume goes to the microprocessor. Well, I know it does, because I've traced it. I think at this point I'll have to stick a signal into it just to confirm that it doesn't work. Still, I'm sure it doesn't work, but at least I should connect a speaker to it if I had one. That's a difficult thing to do because I haven't got one. I'll have to find one. So all I've done is put the top panel back on and connected the speaker up, because we're not interested in the top side. I don't think we are anyway. And squelch wide open. Volume makes no difference, nothing at all. And I don't know, it's just not doing a thing. I don't know why. Anyway, it's too cold out here. I'm going to go back inside for a bit. Okay, so just to confirm something and to check that the audio amplifier is not faulty as well, I've stuck a signal into it up there, 145.60 dBm, which is a big signal, and absolutely nothing is coming up on the S meter. That should be S9 plus 60 at least. So that didn't work, did it? So even though it's now not flashing, it's definitely not receiving. So I don't know where this gets me, but I have to work on this in short stretches, because it does my head in, something as complicated as this. And I've got to where I got to before, really. I mean, all I can do to continue is to definitely check that all the PLLs are producing the right signals. And I think I'll leave that for the time being. I'm just not in the mood for it. That means getting the spectrum analyzer on. But I've done all this before, so I don't know what I'm hoping to achieve. Anyway. So what I want to do now is I want to check the local oscillators are working and locking. So the first local oscillator, it gives you the frequencies according to the receive frequency you're on, and at the moment I'm on 0.1 megahertz, and it should be 391.2. that should be my local oscillator, and I'm just connected my spectrum analyzer input just onto the metal shield around this local oscillator is actually in that box, and the phase lock loop chip is just below it. So what I do is I look on the spectrum analyzer, and although it's not a very big signal because I'm not actually connected to anything except Earth, I can see there is 391.238, which is, I guess, near enough, and it seems to be stable and not drifting. So what's the span on? 22. I think I'll leave it on that. And I guess if I tune the radio the local oscillator will move, which it does. And that's on 3 megahertz now. So I think that's working at that particular frequency. And I don't see a problem with that. But if we go to another extreme, let's say, because I don't want to go through the whole range of it, because I think it's working anyway. Let's try 500. 5. So now on 500 megahertz on the screen, upside down, and I should get 383 megahertz. 383 megahertz. What's that one down there? Looks like 383 to me. Okay, it's not very big, but peak to center frequency. And I tried clipping it on. Yeah, that's on top of the actual case of the local oscillator. So that's, I'd say that's working perfectly. What else can we try? We could try 1025 megahertz. Alright. .1025 megahertz, and what do I see there? 395.85. Try 395 frequency. 395 megahertz. There it is. Oh, it's big, isn't it? This time it's going to vary depending how well it's coupled. I can't see any problem with that one. It's perfectly working, and that's with the Chinese chips in it as well. So they were those PLL chips that I got from China were obviously not fake. That's what I'm assuming. So now I need to go and look at the VCOB, which is that's used for the second conversion. VCOB. This is a bit more simple now because it's only got 5 actual frequencies. So I need to reconfigure slightly. Now VCOB, I believe, is going to be in this metal box here, and with the PLL chip to the right. So I clip onto somewhere around there, and what am I supposed to do? Set my frequency to 0.1. Difficult when it's upside down. 0.1, enter. No, didn't like that. What am I doing wrong here? It's difficult when you're upside down. Ah, 0.1 maybe. Doesn't like 0.1, but maybe 0.1. Okay, 0.1. And I should have 304.8. 304.8. Let's go over to the spectrum analyzer. That's still on the picking up the other one. 04.8. And there we have something. What did I say it was? 304.8. And that's what it says on the screen. So that's the second local oscillator. If I reduce the span a bit, we can see it's a nice stable, not drifting, phase lock signal. Marker 304.8, no problem. So what's the next one? 30 megahertz to 499. Let's try that then. Let's try 30 megahertz. 3. Okay, we're on 30 now, and we should have 788 megahertz. Okay, what am I doing wrong here? Certainly there's nothing there. I could try full span and what's on then on this? Got something on 403. That's not really what I was hoping for at all. Now, if I go below 29 megahertz, which I've done there, I think it needs further investigation of this. Okay, so I think I found my 304 megahertz, which is the second local oscillator, and it goes into a different signal path. So it's actually here. This is the second mixer for the low frequency part of the radio, between 0.1 and 30 megahertz, and here it is, and it's looking good. It's certainly stable, but it isn't very big. It's only minus 54 dBm, but that might be okay. And the main thing is it's there, and it's very stable frequency, proving that the local oscillator works fine. And I'll plug that plug back in. Shouldn't do it live, but I will anyway. So that one is okay, and now I'll need to check the other ones. I think I've already done it, but I'll do it again. So now I'm above 30 megahertz, and I'm back on this particular signal, which is the local oscillator, second local oscillator, and this should be some 68 megahertz, which of course it is. It's a perfect signal, no problems with that. And similarly above 500, so I put 500 in there, it goes away, and it should be on 256 megahertz now. No, I don't want to do that. Frequency 256, perfect signal, very stable, phase locked as it should be, and there isn't much point in doing anymore because I know they're going to work. The next one is 1200 over 1200, and that will be the 768 again. Yeah, no problems. And I'm not even going to check the last one because I think I've already done it. Above 1500 should be 256, which it will be, I'm sure. So that tells me that the first two PLLs are working perfectly, which only leaves the final one, which is in the bit that does above 1025 megahertz on the other side of the radio. So I'm going to turn it back over again, turn it off, plug this back in. If you're confused, so am I. because it's hard to explain what I'm doing, because I barely understand it myself. So where have we got to? There's a wire here. Where does that go? I know what that is. That is the 15.1 megahertz reference for this bit, which generates a converting signal above 1025 megahertz. And here it is here. Look at that, it was easy to find. We have a converter VCO of 1000 up to 1990, when it should be 1010. Actually, I think that's 500. I think it's divided by 2. I'm not sure though. But that all takes place in this box, which is causing the most stress, because when I plug the reference back in, as I said earlier, the display now flashes again, indicating some sort of fault. And I already checked the lock detector earlier, didn't I, which wasn't locked. And I'm on 1200 megahertz at the moment, so I'm going back in the house because wow, a miracle has happened. It's working, well, sort of. I just came in the workshop today and it's freezing cold in here, and I was going to check this converter module, which deals with the frequencies above 1 gigahertz, 1024 anyway. And I had the reference plugged in, which is what seems to upset it, because you get a unlocked signal from the PLL down there, and it was working with that plugged in. And up till now it doesn't make the slightest difference whether that's plugged in or not. And then it started flashing again and not working. So I unplugged it again and now it's working. Most bizarre. But how long will it keep working? That is the interesting thing. I was getting all ready with my spectrum analyzer to try and pick up some signals from that third converter. It should be 500 megahertz, 1000 megahertz, and 1010 megahertz. So just to make sure that I'm not hallucinating here, I'm going to shove a signal into it. No modulation, I can do something about that. Mod. Oh God. What am I doing wrong now? Okay. So, I'm on 145.6, and okay, it's not going to work above 1 gigahertz, but do I really care? No, I've never used it above 1 gigahertz. There's nothing really worth listening to up there, except for a few fairly irritating mobile phone signals transmitting digital modulation. But the big mystery is, how can this suddenly have started working again after many months and years? And what am I putting in? Minus 50 dBm. and I'm getting, well, oh dear, I don't think that's quite right. Minus 50 dBm should be a massively strong signal. So the plot deepens, although it is working. It now seems to be not very sensitive. It's gone off again. I don't get this. I'm going to do further investigations. Oh well, there was a glimmer of hope there for a minute. I just changed to a different channel and it completely stopped working. What is that noise? Noise from the speaker when I changed channel. Absolutely nothing. Volume wide out. I just don't get it at all. It's the first signs of life I've had from this for some time. What on earth is going wrong with it? So I'm back to where I was before. I haven't got a clue. Obviously it's not flashing the display because I've got this reference. It goes to the converter module disconnected. I'll plug it back in. Back to flashing display again. This is what I expect from this thing. So I think I need to lie down after all that excitement. Nothing. Dead as a door now. Why did it do that to me? Gave me such hope. Now I'm plunged into depression again. I'm going to have to do a lot of checks and measurements now. It's almost like there was a loose connection somewhere. I don't know. Well, I wanted to go around and check that converter module. I could still do that, but I don't know what point there is. I'm almost wondering if it's a low voltage problem from the power supply or the regulator, because the power supply over here is basically unregulated and then the regulating takes place inside, because I was measuring what should have been 13.8 somewhere near the middle or beginning of the video, and there is a way of running this on the external DC, and I think I'm going to try that. Well, are you ready for this? Look up there. 14 volts, 1.3 amps, what I'd expect. And look at that. How bizarre is this thing? Whew. I just turned that down. I automatically assumed that 12 volts was a good, within specifications, which is obviously not a good thing to do when it did say 13.8. But we now have a working receiver. I'm not convinced it'll stay working. Let's see what the sensitivity is like. So what am I doing at the moment? Minus 36 dBm. Right, down to minus 80. Still good. Minus 100. Still good. Okay, minus 120. That's more or less what I'd expect for its minimum sensitivity on this particular part of the band. And I'm still trying to get my head around all this, because what have I done? I've changed to a decent voltage, but there have been times, I'm sure, when I've run it on a DC voltage from external, and I've got my thingy plugged back in here now, which has been reference, and that was what was causing it to flash the display when that was plugged in. So maybe we can assume that, well, I don't like to assume anything, but I wonder if I can pick up the phase lock, whatever it's called, from this module. Just going to clip across here. There'll be loads of RF floating around, and I need to go above, and it's clicking. It didn't do that before. If you could hear that clicking, that's the relays in wherever they are, which routes the path of the signal, whether it's below 1025 or above it. And if I look at the spectrum analyzer, I believe I'm supposed to get 500 megahertz off this. Well, I wouldn't really call that 500 megahertz, but it isn't moving, and it's just like flashing its display again. What the hell's up with this thing? And yet it works on the lower band still. So trying to see the display upside down is not a good idea. Right, that's below 1025. So it goes faulty above 1025 megahertz. Well, what do we say about that one then? Looking at that again. That's certainly not 500, as it should be. What happens if we go to, on here it says, what does it say? Up to 1200 megahertz, it's 1000 megahertz divided by 2. 1200 upwards, we get a 1 gigahertz. So if I go to over 1200 megahertz, and look for the 1 gigahertz tone. If I can improve that a bit. That's about as good as it gets. Peak 996. I would say that's not locking properly, although it does seem to be a stable signal. But do you know what? I don't really care if it works above 1025 megahertz. If it all worked down at, you know, the normal VHF band up to a gigahertz, that's all I care about. I don't want to get into this complicated, hideous circuitry down here. Although there is an element in me that would like to know why it isn't working and fix it. But it's just so hard to work on these things when they're so small. I mean, trying to get in there with probes and stuff like that. I mean, there is a slightest chance that when I installed this PLL chip, that one of the legs isn't soldered properly. But I think I'm just going to leave that for the time being. I've really had about as much as I can take of this thing, and it was about to go out through the window at one point, or get smashed up, taken apart and sold for scrap. You know, scrap, sell the boards off. And so I could put that back on, and I think there's another can that goes on there. Maybe it'll like it better if I put its cans back on. I don't think it will. Still works on 145. Still works on... No, it doesn't. It's flashing. Okay. So it doesn't work above 1025 megahertz. I don't care. I really couldn't care. The main thing is it's now working as it should do. And can you believe that? There was a power supply problem after all that time. And so I'm sure the specifications say you can run it on 12 volts external. But I think I'm going to gradually rebuild it now and give it a final test. Or what I'm going to do is I'm going to run it for some time to make sure it still works. And I think would also be a good idea now to check it on various other frequencies. So if I put 500 megahertz into it, 500, and adjust the signal generator. 500 meg ref level. Turn it up a bit. Perfect on 500 megahertz. So I reckon it's going to work all the way from 30 to 1 gig. We could try on 1 gig. Right, 1 gig and 1000, enter. Perfect. HF reception. Ought to try on HF. Let's put 1, enter, and I've got to reconfigure, so I'll come back in a minute. Right, got 1 meg going into it, and works fine. Works fine on the HF. Could try at the high end. Let's try on 28. Perfect, no problems at all. So I'm now going to put it all back together and probably find it doesn't work after I put all the cans and screws back in it. and then I'm going to give her a thorough testing, because as I said, I really couldn't care less if it works above 1025 megahertz. But I may, when I'm feeling more enthusiastic and when it's a bit warmer in the summer, I may investigate that again. But just to get the thing working after all these years is incredible to me. So it's time to get all the cans and screws put back in. But before I box it up, I'm checking the I'm back on the original power supply, which I think's fine, and you get an unregulated, I don't know, 16 volts comes out of there. And then I'm checking the internal 12 volt regulator, and what it says here is connector voltmeter J15, value should be 12.5 volts and adjust to R280, so 12.5 volts. I think it's reading 13 at the moment, but so that's a bit of a mystery, because I'm sure it said at some point when I was checking there should be 13.8 on whatever it was, but it's still working on the external power supply. I don't know, but I think I'm not going to fiddle with it anymore now. I'm just going to put all the cans back in place and give it a really long-term test. The cans on except for this converter module, because I think I ought to check the reference oscillator frequency, but that should be done when the thing is warmed up, and it's pretty cold at the moment, hasn't been on long, so I'm going to leave it, and that should be 15.1 megahertz on that point there. So I'm just going to leave the thing to warm up now. Okay, it's been on about an hour now, and it's slowly drifted down, and now looking at it on the Hewlett-Packard frequency counter, which is a superb counter, we can see we're down to 7 Hertz error, which I think on a radio like this is more than good enough. And you can hear it in the background on an FM station, still working, so I think that'll be good enough for that. So I'll get it finally all boxed up. Right, before I put the final screws into the case, if you're wondering what this little module is, this basically is a low powered FM transmitter, about a milliwatt output, goes through a helical filter because it's got such a poor spectral purity, and that puts out a signal on 101.2, which is not used in this part of the world. And what I'm doing is just retransmitting the audio, which comes out on a socket on the back with a small aerial on it, and that means I can walk around the house, walk around the garden, and listen to what the receiver is receiving on a pocket radio. Okay, let's get the final case put back together. All these screws to put in there. So all back together, and on Radio 4 wide FM, still working. It's going to get a lot of testing now over the next few days, and hopefully it will keep working. Who knows? But that was a long video, and if you stuck with me, I'd be very surprised if anybody stuck with me all the way through. But it was worth it after all, because I never really thought I'd fix this thing, to be honest. And I need at some point, I think, to replace all the bulbs with LEDs, and I have seen them done with blue LEDs. I can't think of anything worse than that, a blue LED in this. I like the sort of orangey warm white look about it. and I think I've got it on dimmed at the moment, but anyway, how do you do this? Yeah, oh, it's on high, okay, because you can dim it. Yeah, fine, okay. Well, that's about it really, and I hope you learned something. I don't know what I learned. I think I learned never to give up on it. But only time will tell whether this will be reliable. So thanks for watching. Bye for now.